Hello everyone. In today's video, we are going to be covering the IXL assignment on multiplication and division with exponents. Before we hop on over to IXL, let's refresh our memories on what those properties and those rules are. Okay, here we have our nice little graphic that contains all of the properties of exponents. But the two that we're going to focus on today is the multiplication one, so a product of powers. Because what does product mean? Yeah, that's the answer to a multiplication problem. And then the division property, which is down here, quotient of powers. Because what does quotient mean? The answer to a division problem. So you may hear them referred to by either name, but multiplication, product, quotient, division, one and the same. All right, let's go ahead and zoom in on our first property, which is the product of powers, so multiplication property. When dealing with exponents, if we are asked to simplify them, this property is going to come into play. One key is that when we work with exponents, we need to ensure that our bases are the same. Because it's kind of like when you combine like terms. If they both don't have the same variable, you can't add them or subtract them. Same goes here. If our exponents don't have the same bases, so in this case, our base is the large letter A, then the property doesn't work. When we have two of the same base, a to the m times a to the n, our product rule says that you can simplify by adding the exponents. So when the bases are the same and they're being multiplied, you add the exponents. All right, let's see what that looks like with an example. If we have 4 to the 7th times 4 to the 3rd, the first thing I need to check is, are the bases the same? Yes, they are. Both of these problems have both of these exponents have a base of 4. And I notice that they are being multiplied, which means I can apply the product of power rules. And that rule states when they're being multiplied, you add the exponents. So same base, so they combine under that same base. That 4 doesn't change, just our exponents do. We're going to add our exponents. So 7 plus 3 is what? 10. Our final and simplified answer is 4 to the 10th. There are times that you may be asked to evaluate, which means you would figure out what 4 to the 10th is. But for this sake, because we're just focusing on learning these properties, we can stop right here in exponential form. 4 to the 10th. All right, let's check out our division property, so the quotient of powers. This is very similar in that the bases have to be the same. If the bases aren't the same, we can't use the rule. So notice we have a base of A, it's identical, only this time we're dividing. And most of the time, not all the time, but most of the time you'll see the division written as a fraction. That's going to start becoming more and more recurring now that you are getting the upper levels of math, where we don't usually use the division sign, we use a fraction instead to show division. If you're dividing two exponents with the same base, you simplify it by subtracting the exponents. So when there's division, you subtract. When there's multiplication, you add. Let's check it out. If we have the problem 12 to the 9th divided by 12 to the 6th, the first thing is we have to make sure the bases are the same. Are they? Yes, they are. We have a base of 12 for both of our exponents. And I notice that they're written as a fraction, which means they're being divided. In order to simplify exponents that are being divided, I am going to subtract them. And I'm just subtracting the exponent only. Your base remains the same. We have 12 to the 9th, and we're going to subtract our exponents. So 9 minus 6, sorry, I said that kind of funny. We have a base of 12 that stays the same, and we subtract our exponents, 9 minus 6. What is 9 minus 6? Yeah, 3. And once again, we're gonna just leave our answer in exponential form, which means we're all done. Voila. All right, now it's time for us to switch on back over to IXL and have a little bit more practice where I can write it out with you and you can see it more like it's live. Here we go. Once again, as a quick reminder, this is the IXL assignment that we are completing, multiplication and division with exponents. So on the left here, IXL is up, and on the right, I took a little screenshot of our properties with that example, so we can have that little refresher of what we need to do until it's memorized, until we've got it down pat. Simplify. Express your answer as a single term using exponents. That's what this is right here. We have a single term. So up at the top, I have 2 terms. I have 4 to the 7th and 4 to the 3rd. So it's now a single term, and I'm keeping it with exponents, so I don't need to go any farther, which is really good, because if I look at the number on that example, that's a big number. So thank goodness I don't really have to do anything with it, so there's no need to actually be scared. We have 505 raised to the 6th power times 505 raised to the 9th. First thing, are the bases the same? Yes, both of these problems, and I'm going to actually go ahead and rewrite it. So 505 raised to the 6th power times 505 raised to the 9th. Are the bases the same? Yes, our bases are the same, which means I can apply these properties. I can apply these rules. And what's the operation? So remember, operation is multiplication, division, addition, subtraction. I notice the operation is multiplication, which means we're going to use the product of power rule. And that product of power rule says if the bases are the same, which they are, and they're being multiplied, which they are, what do we do to the exponents? We add. So we are going to add our exponents together. The base will stay the same, 505, but our exponents get added together, 6 plus 9. What is 6 plus 9? Here we go, this gives you a second to think while I fix my mistake. $15. 6 plus 9 is 15. Did we follow the rules? Did we meet all of our directions? A single term? Yep. Left it with exponents? Yep. So we're good to go ahead and type our answer in. Have our exponent button here, 505 to the 15th power. Perfect. All right, let's see if we can get another type. Here we go. Same directions though. Simplify, express your answer as a single term using exponents. I'm going to go ahead and rewrite my problem, because this is something that you guys may get to the point where you can do a lot of this in your head, but there are going to be times in math that when you're working from a computer, you do need to jot it down on paper. And I'm someone that I do that most of the time anyways. Even if I can do it in my head, I usually still jot it down on paper just because it helps me ensure that I don't make a mistake. All right, first thing, I know I'm dealing with exponents, but I better make sure that the bases are the same. Otherwise, there's not much I can do. Do they have the same base? Yes, they do. We have 520 and 520. So now What's the operation? I see a fraction, which means division. All right, if they're being divided, we can use the handy-dandy quotient of powers property. And that property says when you notice that exponents with the same base are being divided, we just established that they are, what do you do to your exponents? Subtract. We are going to subtract our exponents. So the base remains the same, the exponents are subtracted. Our base remains the same, 520. And then we will subtract our exponents, 87 minus 48. All right, with this, I encourage you guys to do as much of this either with mental math or work it out on paper. Don't use a calculator for this because you won't get a calculator for every single problem on your state test. Therefore, when it comes to problems that can be done either mentally or by working it out, I want to encourage you to do so because we don't want to rely on that calculator. So I'm going to work it out to the side to refresh your guys' memory in case it's been a minute and you got a little calculator addicted, so you can remember how to subtract. 87 minus 48. I'm going to change my pencil width here because it might be a little wide. All right, 7, when you subtract like this, remember the larger number needs to be written on top, and then you work from the ones place over, so right to left, backwards of how you would read. 7 minus 8, can't do that, which means borrowing comes into play. So we're going to borrow from the 8, which will become a 7, and since we're borrowing tens, we're borrowing one set of tens, our 7 is a 17. So 17 minus 8 would be 9. And then 7 minus 4 would be 3. So there we go. Not that hard. So definitely want to make sure we keep our brains sharp, and whenever you can, work it out on paper or do it in your head. All right, our base is the same, 520, and our exponent, as we just discovered, is 39. So there we go. Click that blue button to insert my answer. 520 to the power of 39. Beautiful. All right, now this is an example of one. I'm not going to do it, but this one you could probably do the subtraction in your head, right? Yeah, because we'll kind of just do it mentally here. They're being divided, which means we use the quotient of powers. Therefore, we subtract our exponents. 89 minus 1, 88. And I was going to jump up a level, but it won't let me. So I guess we just quickly solved this one together. So let's do that one more time because I would love to see a slightly tougher example. If not, I'll just create one. Here, this is a good one. Okay, simplify. Express your answer as a single term using exponents. 932 to the second power divided by 23 to the ninth power. Ooh, so many numbers. But hey, that is why I copy it down, because it would be very easy to have kind of a backwards moment like I did and make a goof. I'm going to double check that I copied it correctly because that would be a shame if I didn't. Good to go. Okay. Oh, I see here I need to simplify. Is it set up as multiplication or division? It's set up as division, so we're going to be using the quotient of powers, and that states when the bases are the same, which they are, we do what to our exponents? Subtract them. So our base remains the same, but we subtract our exponents. This part is key. If we look at our rule here, notice that they took m minus n. our numerator exponent is subtracted from our denominator exponent. Therefore, it is 2 minus 9. So now we're dealing with integers, which means positive and negative numbers. Remember, when you add and subtract, if both of the numbers have the same sign, you add them and keep the sign. If the numbers have opposite signs, so one is positive, one is negative, you subtract them and take the sign of the bigger number. When I look at this, I notice that they do have opposite signs. I have a positive 2, and then this minus sign is a negative, or I know some people like to rewrite it as plus a negative, which means we have a positive number and a negative number. Therefore, that rule that I just said is when the signs are opposite and we're adding and subtracting, subtract and take the sign of the bigger number. So first off, our base stays the same. If I subtract, 9 minus 2 is what? 7. And then we take the sign of the larger number. 2 or 9, which one's larger? 9. And 9 was negative, which means our exponent is negative. And in this case, it does not tell us to write our answer with positive exponents. So it looks like we're going to be allowed to leave our answer this way, even though that's not standard form. But the reason why is because IXL is trying to just get you to practice multiplication and division only. So do be careful. That is one thing about the division problems, is since you're subtracting, you may run into situations like this. So just be careful that you don't mess up your negative signs. All right, this is actually the problem I was hunting for. So it's perfect. This is how we're going to end our video here. Simplify, express your answer using single term exponents. So same directions, but I got a little bit more work. This would definitely be one that I would encourage everyone to jot down on paper, because there are going to be 2 different steps and you don't want to make a mistake. What do you guys notice is a little different about this problem? Hopefully, you said that you noticed we have both division, because we have a fraction, and we have multiplication. So the tricky part is, what do you think we have to do first? If we have to do both of them, which one do we do first? In this case, we are going to be multiplying, so the product of powers first. The reason for that is it actually takes us back to order of operations, because order of operations is king. It rules all. And that tells us the very first thing in order of operations, PEMDAS, please excuse my dear Aunt Sally, is I need to do any parentheses. Well, parentheses really means grouping symbols. And one grouping symbol is a fraction bar, because I can't divide until both the numerator and the denominator are simplified. So this right here, it's like it's grouped together. I need to simplify that to make it one exponent. Then I can use the quotient of powers and divide. I'm going to go ahead and just rewrite my numerator real quick, because I don't want to forget about that. Let's do a different color, because we want to make sure our different steps can stand out. But we are going to take our denominator and use the product of powers to simplify. Remember, with the product of powers, if we notice that 2 exponents have the same base, 247, 247, and they're being multiplied, we add our exponents. That means we are going to be adding 92 and 1. So what's 92 plus 1? Yeah, 93. Now that it's simplified, we are ready to now that the denominator is simplified, we've gotten rid of that grouping, we've gotten the parentheses, now I can do that division. Now I can apply the quotient of powers. This one we've practiced a lot in the video, quotient of powers. If we are dividing and they have the same base, they do, 247, 247. What do we do to our exponents? We subtract them. We're going to take 98 and subtract that from 93. As you've probably noticed, I'm showing you a different way to show your work if you don't want to rewrite every step. What's 98 minus 93? 5. And we are finished. We have our answer in single term exponents. Woo woo. So it looked really complicated, but it was just combining the two properties. We needed to do product of powers first, then we could do quotient of powers, and we're finished. But we gotta make sure we're correct before we hit end. And we got the nice little that's right. Okay. As always, everyone, please, if you have any further questions, reach out via email to your teacher, or of course, come to our help session. And good luck with the assignment. I know you can do it. Bye.